Hello, everybody. This is Emmanuel Rains, and today I'm going to talk about the history and impact of mechanical engineering. All right, to understand the history, we must understand what is mechanical engineering. Well, mechanical engineering is the application of engineering principles to design, develop, and test machines, processes, and systems that move. Mechanical engineers use their knowledge of energy, motion, and force to create technologies that meet human needs. Alright, so when was it first introduced? A little bit complicated, so let's get into it. The concept of mechanical energy was the relation of the idea of mechanical equivalent of heat. Now, James Prescott Joule in the 1840s, who conducted many experiments between mechanical energy and heat, he himself was laying the groundwork for the first law of thermodynamics. Now, while Joule was credited with establishing the idea, early philosophers like Leibniz and Galileo explored concepts related to the conversion of energy, of motion. And I'm sorry if I butchered their names. This picture right here is basically James Prescott Joule. Thermodynamics is a science of the relationship between heat, work, and temperature, and energy. Now, thermodynamics also transforms and deals with the transfer of energy from one place to another and from one form to another. Now, the key concept is that heat is a form of energy corresponding to a definite amount of mechanical work. Now, there are 3 laws, but I also include that zeroth law. There's technically 4 laws if you include the zeroth law. But let's talk about the 3 main laws so that you mainly need to learn and know. Now, the first law states energy cannot be created or destroyed, or in thermodynamics term, heat cannot be created or destroyed. The same thing has been one of the biggest sayings in the universal for forever now. Now, the second law states, for a spontaneous process, the entropy of the universe increases, and the third law finally states, a perfect crystal at 0 Kelvin has 0 entropy. Now, as you in the picture here, this is a little bit more of an examples on how the first, second law, third law work, and the zeroth law work. As you can see here, the entropy of a system approaches constant as the temperature approaches absolute zero. You see here some major inventions for mechanical engineering work. So let's talk about it. In 1698, Savery had obtained a broad patent for his pump. Now, Newcomen could not patent his engine. Now, due to that Newcomen entered a partnership with Savery. This became the first recorded Newcomen engine, which erected near Dudley Castle, Staffordshire, in 1712. Now, Newcomen invented the internal condensing jet for obtaining a vacuum cylinder and an automatic valve gear. Using the steam at an atmospheric pressure, he kept it within the working limits of his materials. Now, Newcomen's steam engine was used in the draining of mines and in raising water to power water wheels. Actually, this is kind of the first design of the Newcomen steam engine. You see here, you're pulling up water from here, as you would usually have a bucket right there pulling up water, and so, boom. Now, the sewing machine. In this picture right here shows how, now, he invented the first practical sewing machine, but in the first recording of the sewing machine was created by Thomas Saint in London in 1790. Now, Thomas Saint created the first design, but a sewing machine is a device that stitches fabric and other materials together with a thread. Now, a sewing machine uses a needle and a thread to stitch fabric together in an up and down motion. Early sewing machines were powered mainly by spinning a wheel, but now modern sewing machines are powered by electricity. So, back then, you have to actually generate electricity, but now it just runs it off by itself because of the advancements that we have had in technology. And now let's move over to mechanical refrigeration, or known as air conditioning or refrigeration. It's a process that uses heat, that uses a heat exchange system to remove heat from a specific location. It is based on the first law of thermodynamics, and which states that heat cannot be created or destroyed, only moved from one place to another. Dr. John Gory expanded on this idea, but Oliver Evans, an American inventor, designed a blueprint for the mechanical refrigeration. Now, in 1934, the first practical mechanical refrigeration was built by Jacob Perkins. But as I mentioned before, Dr. John Gory took that blueprint and invented to a whole new level. And also, mechanical refrigeration removes heat from space by using refrigerant to absorb heat when it boils and releases heat when it condenses. This picture right here is the most simple version of how it works. So if you start, it's a more, you don't start somewhere, but you start, let's say here, you start from right here, the evaporator, you go to the compressor, it goes over to the condenser, and on to the receiver to receive the high pressure vapor. So the first fuel cell, or known as gas batteries. Now the fuel cell works like batteries, but they do not run down or need recharging, meaning they produce electricity and heat along as it fuels is supplied. Now, the fuel consists of a negative electrode and a positive electrode. They are surrounded by an electrolyte. Invented by Sir William Grove in 1838, but it was introduced to the public by 1839. And the concept of reversing the electrolysis, the process to generate electricity from hydrogen and oxygen. Solar power could be one of the most biggest, if not one of the biggest things in the engineering world, and just specifically mechanical engineering. Now, solar power is also known as solar energy, as the process of converting the sun's energy into electricity or heat. Now, solar power is a renewable energy source that can be used for many purposes that includes heat, electricity, and even light. Solar power has been around since the BC times, but they have been many contributions to explaining the idea of solar power. Now, during the 7th century BC, people used solar power by reflecting the sun's rays onto shiny objects to start fires. Therefore, on from the 1800s to the late 1950s to the early 1960s, there have been many ideas to expand upon this idea of the use of solar energy. For example, in 1939, French physicist Edmond Becquerel discovered the photoelectric effect, which is when certain materials produce an electric current that when exposed to sunlight. In 1973, English electrical engineer Wilbur Smith discovered that selenium had a photoconductive potential. In 1976, Professor William Gurles Adam and his student demonstrated that selenium could be used to create electricity to sunlight. In 1983, American inventor Charles Fritz created the first solar cell using selenium wafers, and it started on a rooftop in New York. Now, in 1939, Russell Oil created the solar cell design that is used in many solar panels. 2 years later, in 1941, Russell Oil patented his first solar design. Finally, in 1958, the Vanguard 1 satellite became the first spacecraft to use solar panels. As I mentioned before, the previous picture, you see this is the panel, flex off, and it converts the sun energy into electricity, which goes to the electricity box, which generates electricity inside the house. In simpler terms, let's get on to machine guns. Now, by harnessing the energy released in the firing cartridge, Maxim produced a weapon capable of discharging multiple bullets by simply activating the trigger. Now, Maxim's machine gun was water-cooled and belt-filled, with a theoretical rate to fire up to 600 rounds per minute. Now, the modern machine gun was invented in 1884 by Harold Maxim. The machine gun had a heavy impact on wars such as the Spanish-American War. Automobile could be described as the biggest advancement in the mechanical engineering world. German 29, 1886, the German inventor Carl Benz patented the first three-wheel motor wagon, or vehicle powered by gas engine. Now, this could be regarded as the birth of the automobile, but let's dig a little bit more into it. Now, cars work by using an engine to overcome forces like gravity, air resistance, and friction to move. Now, there are many components that make the car work, including the engine, transmission, chassis, cooling system, exhaust engine, and a battery. Now, engine could be considered the most important part of the car because the engine converts energy from burning the fuel into mechanical work or torque. Now that turns a wheel. Now, most cars use an internal combustion engine, which has cylinders, pistons, fuel injectors, and spark plugs. Now, the engine goes through a 4-stroke cycle: and intake, compression, combustion, and exhaust. This is the basic modern day automobile right here. As you can see, the fuel tank, and you got the fuel pump, soft engine. So they kind of the fuel line connects more to the engine. You see the batteries right here, the engine and the electronic control module. So that's on the Industrial Revolution. Now mechanical engineering played a pivotal role in the Industrial Revolution by developing and utilizing machines powered by steam engines, which enabled the mass production of goods in factories, drastically changing the way products were manufactured and leading to significant advancement in transportation. Now, those examples included steam locomotives and steamships. The revolution made a major emergence as a distinct profession during this period. Now, the impact this had on wars. Now, in both in World War I and World War II, mechanical engineers and engineers in general were very important to the war effort in developing necessary machinery, aircraft, weapons, and more to help win the war. Now, mechanical engineers contributed to the design and improvement of the fighter airplanes, tanks, vehicles, machines, and more. Now, during that time, the first computers were developed. Those computers were very much mechanical devices with electronics. Now, a lot of those mechanical computers were funded by military projects, and during that thousands of mechanical engineers got together to develop the jet engine and the space rocket. As you can see right here, it's basically this. Now, the impact this had on modern society. Now, mechanical engineering has made a significant impact on modern society. Those ways include creating products and technologies, improving sustainability, improving human health, making life more convenient. Now, integrating emerging technologies and even optimizing production process. Mechanical engineering is a versatile field that draws from physics and material science, in which you didn't know. If you want to be a mechanical engineer, you need to understand physics at a very high level. It's going to be very important for you in the future. Then you have some well-known, engineers. So let's get into it. Nikola Tesla, obviously, is well known for the design of the modern alternating current electricity supply system. He also contributed to the radio technologies and is often known as the father of radio. George Stephenson, this was a British inventor who created the first inner-city railway system. He's also known as the father of the railways, and this, of course, reshaped the transportation and the industry. Now, Uriah Stodola, he began the study of thermodynamics and was even a professor of Albert Einstein himself. He most notably invented the first heat pump, contributed to the beginning of the steam and gas turbines. This is basically here a picture of the modern day and how the machines built the cars. You see the engineer right there. He's kind of working on a little bit to improve it, and then she goes around here, starts from the machines, and they build certain parts. So this is a very much a modern idea or a modern picture of how engineers work nowadays. Now, the overall summary is that mechanical engineering history is one complicated thing, but without these inventions, we wouldn't have the things we have today. Now, the impact of mechanical engineering has had on our society is nothing less than significant. The advancements on technology, health, and overall well-being. And that is all. Hello guys, as I'm in this video right now, I realized I cannot talk at all. I'm dealing with a little bit of a messed up throat right now, so I'm sorry for the inconvenience of me not being able to talk English. Thank you very much.